Again, I have the Soflogix PLC connected to the Arduino running the ModbusTCP script, and I have my proto board here, and again my Peltier little freeze with the relays and a thermistor glued taped to the inside of it. I'm here trending the temperature and the set point of the PID control loop, and you can see on the left side the virtual rack of Soflogix, and here on the upper left corner you can see this, which I named Rockwell Bridge, which is something I wrote on C#, which you can see here has some libraries. One of them is the Advanced HMI library to talk to the PLC, and the short bus to talk to the Modbus. And you can see here all the PLC tags. These are the input tags that I write from the Arduino into the PLC, and these are the analogs, and these are the outputs from the PLC back into the Arduino. And this is just data handling. It's bridging data from Ethernet IP on the virtual rack back and forth between the Arduino. And I have inputs as I's, and channels as analogs, and Q's as outputs. And this is Studio, but I'm running it already compiled. So this is a compiled runtime. And you can see here I have some inputs. I have a timer, and back there is a power supply, but I'm gonna press this button to reset the latch, and if I latch it, it will start the timer, and it will pulse it every second for 10 seconds. Here we go. You can see it's latched, timer is running, and it's pulsing the other LED once per second. Okay, once it's completed, the second LED Q1 lights up. And I also have one of the analog channels connected to a voltage divider, again made by the thermistor, and a 10 kilo ohm resistor in a proto board. And it runs to the freezer, and I have a little 12-volt power supply connected to the H bridge with relays, which are driven by NPN transistors on that solder board. And here I can show you the set point and process value temperature running on the PID control loop. I want to see if it's stable. Okay, I changed the set point now, and it's a little oscillation on the trend, but it's stabilized around. It's a little oscillation. Okay, I want to change it back 13, see if that step change causes the loop action. So see, set point dropped, and we should start seeing the temperature inside the freezer to drop. And now it's finally dropped, and it's reached the new set point. I want to now raise it back to 18 to see the response of the control loop. Using PI only, there's no differential part of it, and it's the independent function equation that I'm using on the PID. And let's see, rate of row, so it's going to take, the trend is 10 minutes long, and it's updated every second. So set point is 18. It's going to start to heat up the inside of the little freezer. And once you see that, it'll overshoot, but it reached the new set point. And I changed the functions of the LEDs to show when it's heating or freezing. Heating or cooling, which is cooling is direct, and heating is reverse action of the PID. And you can see it's way faster.